Hello and welcome to a new Dungeon Crawler Toolkit tutorial. In this tutorial I am going to show you how to add new monsters. So I'm going to show you how to change the existing monsters, change their meshes, change their stats, stuff like that. And then at the end of the video I'm going to show how to add entirely new skeletal meshes and how to set them up with animation blueprints, etc. And I'm going to show the end result here first. So I've got my decked out adventurers, and let's enter this arena and challenge this monster. So you can see we got this spider. Apologies to the arachnophobes, hopefully we were warned by the thumbnail, but this is from the Infinity Blade Adversaries pack that Unreal Engine gives, or that Epic gives away for free. You can see that he can attack us. If we move away, he follows along, and if we deal enough damage, we should be able to kill him. Come on. There we are, and a death animation. So yeah, this is what we're going to have at the end of this video. So with that intro done, let's get started. Right, so here we are in the arena map, which is the map I like to use for testing, since we have a lot of items to work with here and we have an arena we can enter. So I'm going to put our monsters here within the arena, and then we can face them whenever we are ready. Start location is here. So first we're going to start by modifying an existing monster we have. So we can do that through the data table we have for monsters. So let's go to data, and then we'll have DT monsters here. And you can see all the default monsters that are included in DCT. So we have various ones to choose from here. You can create a new one, like by adding, or we can duplicate one of the existing ones to have a starting point. So let's start with the slime here, and I'll create a duplicate of it. So I'll call this then the wood slime, because we're going to use a wood material for this one. And for this we want to keep the same skeletal mesh here, and also the same animation blueprint. So if you change the skeletal mesh, you will have to change the animation blueprint to one that fits that skeletal mesh. Then we have the stats here. We can change these up, not that important for this tutorial I guess, but we can, do things like decrease its health, so now it has only 50 health, and we have various other stats that we can manipulate here. So you can add new types of stats as well, and so you can just add more of them. These are the ones that the monsters use by default, and these are the ones that are utilized in the BP monster blueprint. But yeah, if you want to add your own functionality, so your monsters are using different types or more types of stats, that's where you would start by adding them and then implementing the logic within the blueprints. But yeah, anyway, that was a digression. You have other things here like the material overrides, so that's the one that I already said I was going to change. I want this monster to have a sort of wooden material instead. So a slime made out of wood, maybe it doesn't make too much sense, but let's set this to light wood, and we'll place our monster here so we can see the changes that we make. So let's go to blueprints and then monsters, and you see here that we have various types of monster blueprints here already, but actually all of these monsters here, except the first one, are just child actors of BP monster with a single variable changed. So if we go into the fire slime, for instance, you can see here, well, all of these are actually set to the defaults. The difference here, you can see by this little arrow, this is changed, that the monster that we are selecting in our data table is a different one. So if you drag this guy into the level, or you drag just BP monster, and then you find the monster type here, and just change this to fire slime, you get the exact same monster. So these are just here so they're easy to place in your levels. You don't have to go and change the data for each of them, but they function the same way. So in this case I'm just going to use BP monster. I won't create another blueprint for this, and then I'll just change the row name here and I'll set it to our wood slime. So here we have our wooden slime. I guess I'll rotate this guy around so he's facing where we are entering, so he will see us and start attacking immediately when we go in. So yeah, we changed the material. Now he's a wooden slime. We can see that this works. Just to get started, let's get our key. And this is the slime, and yeah, you can see us and he can attack and everything as expected. This guy, since we set his health to something lower, he should die pretty quickly. 30, I mean he has 50 life, so one more shot and yeah, he's down. Okay, so that works. We can change various other settings here as well. This mesh relative transform, you can use this to offset your the skeletal mesh of this blueprint in various ways. So yeah, we'll see ways in which this can be useful at a later point, but just to show an example here, we can set, you know, the scale of this guy to something higher and then save. And yeah, what you will notice, this is important to know, that when I change the scale here, you see no change when I go back to our map here immediately. And that is because this blueprint is changed in its construction script, and the construction script only runs when anything with this actor is changed. So that means this monster will not be updated if we have updated the data table before we do any sort of change to it, or reload the map or things like that. So for instance, if I just move it back and forth, then we see that the change took effect, and this guy's really big. We could do the same thing by just, you know, checking and unchecking any sort of variable in it as well. So that's just worth keeping in mind. But yeah, let's put the scale on this guy back to 1. And then we can add projectiles if we want. So we can have this guy shoot like a dart. And if we want him to shoot, we probably want an attack range. So let's say a range of 5, that's 5 tiles. And we want to again move this guy. Yeah, I need to get this key every time. Maybe this isn't the best testing stage after all. But yeah, now he's firing arrows at us, as you can see, and they are hitting. Okay, so that's it for projectiles there. You can change the offset here, so if you want the projectile to fire from a different point at this mesh, you can do that here. You can change the sounds that it makes when it hits you. And the barks, like these are random sounds the monster will make while it is moving around. You can add some of those, or sounds when it dies, things like this. And here you can adjust how fast the monster is moving, how fast it is attacking, etc. So we can set the move speed to something really high. And yeah, I'll keep set a low attack delay so we can keep attacking. Though this is still constrained by the speed of his attack animations, but there will now be a shorter delay between attacks. And yeah, and we can have that when he hits us, he hits all the characters in our blob and not just a random one. So now he should be a bit more annoying. Let's get our key. And yeah, now all of us are getting hit. He's not shooting that much quicker because the animation is still slow, but we can see, yeah, he's moving quite a bit quicker, even though his turning is still slow. So that's the most important things you can change in the data table settings here. Although the last one here is also worth talking about. I won't get too much into it in this video, but if you want to have more advanced changes, if you want to have your own functionality that is not supported just by the data in this and by the functionality that is defined in BP Monster, you can add your own child blueprint classes. So you could, from this blueprint here, BP Monster, create a child blueprint, and you could, in the same way as you would in any child blueprint, override functionality in the parent blueprint or add other functionality on top of this and so on. And then you could change the monster class that is used here to that specific one to have the monsters, whatever monster that uses this this monster type will then utilize that blueprint instead of the base BP monster blueprint. So to give like a quick example of how this could work, I made a child actor here, and in this all I want to do is to take the skeletal mesh and I want to put the location up like 100 units. That's actually a really bad example because yeah, the transform is being overridden by the data table in the construction script, so that won't actually work. If so, you would have to override and change what happens in the construction script. But yeah, let's take an even simpler example. We want on tick, we want this this monster to print a hello string that lasts for, you know, just one frame like this. So now, yeah, let's just move our guy into the room here so we don't have to open it with the key every time. So currently we see no print string going on because we're still using the old blueprint, right? But if I go into the DT monsters here and then I change the type here to BP monster child and save and then manipulate this guy in any sort of way, now we can see this constant hello print string going on in the top here. Oh yeah, and I guess this attack speed is really fast. I just didn't manipulate him so it was implemented the last time. Oh, he can kill us real quickly. Yeah, so that's important to remember. I repeat again, though when you load the map it should also be reset just while you're testing. Or like when you package a project also it will be set correctly, but when you're testing remember to manipulate these monsters in any way when you are changing the data table so that they take effect. You can see that it is easy to forget as well. Okay, good. Right, so that's for manipulating the data. Now for the main course of adding a new skeletal mesh. Like I said, we have imported here the Infinity Blade Adversaries spider. So this is from the Infinity Blade Adversaries pack of that name, which you can find for free on the marketplace. It's made by Epic. You can use those assets in your own games also, as long as they are made with Unreal Engine. And so here it is. We have this spider and we have a ton of animations. A ton of great animations here, so there's a reason I chose this one. We have so much really to choose from if you want to go wild and create a larger animation blueprint later on. We won't be using too many of these animations, but we'll be using like a attack animation for sure, and an idle animation, and a death animation, and also a walk animation. So we have a lot to use here for our monster, which is fantastic. Spiders are also, of course, one of the all-time greats in the dungeon crawler genre, so that's another good reason to include it. Okay, so we will need a animation blueprint to use here. So I'll go to the place where these are located, which is in characters. I could create a new folder here for the spider. Maybe I'll do so. Though I won't move stuff over from the folder here. I would do so if I wanted to include this in the actual project, but yeah, no point in being overly cleanly in that way now. So I'll just add the new stuff I'm making in here. So I'll right click, select animation, and then I'll make a animation blueprint, which we find here. I'll base it on anim instance, and the skeleton will be the spider skeleton. So I press OK, and we have a new one. I'll call this ABP spider, like this. So we have a blank animation blueprint at this time with nothing in it. So we could start building everything up from scratch, but we want to use much of the same functionality that we have in our other animation blueprints. So let's open one of those so we can base it on those. So I can get the slime, or yeah, the skeleton blueprint. Both of those are fine, and I can go into the ABP skeleton here. So this is the one that we will base it on. Now, unfortunately, in Unreal Engine, you can't have a animation blueprint be the child of a different animation blueprint if that animation blueprint uses a different skeleton. Yeah, not skeleton as in this guy, but as in, you know, skeleton. This feature. So that means that we can't just make a child blueprint. Unfortunately, we will have to duplicate some code. and that's just how it is. But I have made it so it will be a bit simpler. You don't have to implement anything or change anything outside of the animation blueprint. The animation blueprint can handle all of these differences on its own, and I do this through a blueprint interface. So a blueprint interface, if you don't know, it's a way that various blueprints can share basically the same functions or the same events so that they can be called on by other blueprints on those blueprints. So you don't have to cast to that specific type of blueprint to run that event. You just run that interface event, which can be defined on all sorts of different blueprints. And each blueprint that implements this interface will have its own definitions of what it actually does when those events are called, but the events themselves can be shared. So by having this interface, we can then add that to our animation blueprint spider here. So let's go to the class settings. Here is interfaces. We will add the BPI animation interface. So, and compile and save. And this means now, I'll just delete this default stuff. When we go here, you see that we have these events that have this interface sign. So these are from this BPI interface, blueprint interface, BPI animation, I mean. So now I can copy all of these safely into ABP Spider, and we can have the same events here. So this means that when BP Monster, the blueprint that our monster uses, wants to try to animate the skeletal mesh that it has, it can use these interface events no matter what animation blueprint the monster is actually using, as long as they have the same interface events. But that doesn't mean our work is entirely done by any means. If we compile, we should get some errors, and we see that we do because we didn't copy over the variables. We still need to add those, but that's quickly done. We can just right-click them and create these variables here. And now we have these variables on this animation blueprint as well. So we have this part, and that should be working fine, but all of this needs to integrate with the actual animation stuff, which happens in our anim graph. And again, I will want a starting point here. I'll just use the skeleton anim graph, and I'll copy over the state machine, and I'll place it here. I'll just rename it to then spider state machine. Why not? And plug this into our output post. And again, when we compile, we should get some errors, and we have several, which is not surprising because the state machine is trying to use the skeleton animations. I shouldn't have chosen skeleton as the base here because it confuses it with the skeleton here, but yeah, it's using the animations from our skeleton monster. So we want to change that. So let's go into here. So first we will need then an idle animation, but for idle in this, we're not actually using a simple animation. This is a blend space which blends between idle when the monster is standing, and then some sort of moving animation when the monster is locomoting. So we need to make a new blend space for this, and we can do that. Let's go to our spider folder and right click and animation, and I'll then do a blend space 1D. I'm just doing one dimension here from 0 speed to the maximum speed we're expecting. So I'll create a new one, and I'll base it on then the greater skeleton, greater spider skeleton, and I'll call this and BS for blend space, and let's see, spider. I mean, yeah, maybe I'd use a more specific name if we had multiple blend spaces, but let's just call it that. And for this, I'll add our idle animation to the speed of 0 here, and then we'll have the walk forward for a speed of 100. We can see then that as we blend from 0 speed and upwards, he will start, walking. This is, yeah, it's not the smoothest blend actually between these animations. Maybe they're not really set up to be blended between each other, but yeah, it's showing a principle. It might look a bit weird when we do it later, but yeah, that's how you can use a blend space. If you just want to, straight up go from an idle animation to a walking animation without any blending in between and so on. You can set that up in in the state machine, so you just have two separate states. But let's do it the blend space way. So now we have a blend space. We'll find this here, and we'll take the BS spider, and I'll input the speed into that. Still, we're getting compile errors because we have many more animations to set up. So here in this state machine, we start in idle when the game starts. You can see in the event graph here that there's a speed interface event here that feeds into this blueprint from the BP monster blueprint and sets the speed. And this speed is then used in our state machine in idle to set the actual animation, if it's moving or if it's standing idle. And then from here, if attack is set to true, then we go to our attack animation. You can see that this happens when this interface event attack player is called, then attack is set to true. So let's go here. We need another attack animation, so let's find one. We have many good to choose from here, I think. So yeah, melee 1, that's a bit much maybe. Yeah, there's one. Yeah, and this one is just mirrored, it seems. Okay, so let's do this. Then left hook from our spider, and it's called melee B. So let's go back to the blueprint, and we'll find then melee B. We don't want to loop this animation. I'll compile it. We're still getting errors naturally. And we want to return to idle. So in this case, we can say, okay, we are allowed to return when the time remaining for our animation is 0. I mean, for the old one I have less than or equal to 0.1. I don't think that's actually necessary since we get a smooth blend anyway. Oh yeah, that's... we will need to find another, let's see, time remaining from this attack animation here, and we'll say that when this is equal to 0, then we want to return to idle. So that means when the animation is time remaining is 0, we go back to idle. So that's fine, and this should be working. If we're dead, we're going to the dead animation. If we are attacking or if we are idle, we just go straight to dead. But we need a dead animation here, and I believe we have a good one. And we saw it earlier. There it is. Very dramatic. So we'll find this, death. Great with all these context-sensitive blueprint stuff. When you drag a pin out and you start writing, then and this is checked, then Unreal Engine will find the stuff that's relevant. So it's easy to find the correct ones. Okay, now I compiled and we can see that compilation was successful, and we can actually see our spider moving here. So we are well on our way to have a functional spider enemy. There's still more to do though, but let's see what we have so far. So we'll need to add an entry to our monsters. I'll base it on slime again, why not? And then we at least get those slime sounds, which I guess fit decently well with a spider. I'll call this spider. And then I will want to set the mesh to this greater spider and the animation blueprint to then the spider. And then I save. And then yeah, we have no monster at the moment. Let's find our monsters. BP monster. There he is. We'll turn him around. And we'll find the monster type here, and I'll change it to then spider. And yeah, so there's some weird stuff going on. One thing is that our wood material should be overriding one of the materials here. Actually, I can't see it. I'm guessing that this spider has a lot of different materials. No, wait, we didn't. We copied slime, not wood slime, so we're good. But I can show that. So if yeah, that is provided this spider actually have multiple materials. Let's see. I will add a so small digression here. Material override for this spider. I'll find our wood texture again. I'll save and I'll move this guy back and forth. Yeah, okay, seems like it just uses a single material, so the entire thing changes. But if you have a monster, a skeletal mesh that uses many different types of materials, then you can in the data table add more materials here, and they will be added and override the materials in the order in which they are assigned within the skeletal mesh itself. So, but of course we don't want to have that here. But yeah, let's go out, let's drag this back and forth, and let's see how he works at the moment. So he's moving, but he's moving like a crab, and then he attacks and he just stops. So, and we didn't take any damage either. So there are a lot of things we still need to fix here, but yeah, shouldn't take too long, so let's get to that. First, we want this guy to be facing in the right direction, right? So we can do that in this thing I mentioned earlier that we were going to get back to with the mesh relative transform. So I've tested with this mesh before, so I know that our rotation here, we need to set this at the Z rotation to minus 90 degrees. And then if I save and I drag him back and forth, we can see that he's facing the correct way. So if we're playing now, he's moving towards us, and oh, it's pretty scary, and he's attacking. But then he stops, so something is not right with our attack animation, obviously. So let's try to figure out what is happening here. So let's go to our animation blueprint, back here, and we'll see that we're in attack, and for whatever reason we're not returning to idle here. So we are returning to idle when the animation time is at 0, and that should actually be triggering. So something else is happening here. So the reason is probably, yeah, is certainly that we're setting attack to true when we are attacking, and then attack is never set to false. So immediately when it returns to idle here, attack is still true, so it goes back to attack, and then it stays there, and the animation is stuck because we're not looping it, and then he just stands still. So you can see that there is something set up here for setting attack back to false, and also for this calling attempt attack, also an interface function on the owning actor, which is the blueprint monster, which performs the actual game logic part of the attack. But this thing is clearly not triggering, and this is an AnimationNotify, which is something that can be added to any animation. And let's remember the name here, attack hit, because we will need to re-add this one. So let's go to animation, find our attack. Yeah, we're already here in melee B. So this is the one, and we want to notify when this attack hits. So this is the moment where we actually deal damage to the player. So we'll find the moment that looks most appropriate. Yeah, I guess there is when it hits roughly, and then we will add a notify here. And it's not, yeah, it's already here actually, because I added it during testing, but I don't think you will see this notify in this case, and you will have to add a new one. As soon as you have added it, you will see it later on, but when we copied it manually over from a different animation blueprint, as we did, you'll just have to, the first time at least, remember the name for it, which is then attack hit. There, and then it should function automatically. When the animation gets to this point, the animation blueprint will then run this event, which in turn leads to our the gameplay logic part of dealing damage, and then setting this variable back to false so that we can return to idle. So let's see if all that works. Again, I move this guy, and now he should be able to deal damage to us. And yeah, we can see here that we are taking damage, and then he will keep attacking us again. Yeah, so that is working well. And we should have a working death animation as well. We don't have any weapons here because I'm not in the room, so let's equip our powers and try to kill this guy. There we are, smack. Oh, and this is looping. Good thing we checked. So we will need in the spider to find in the state machine here, dead, and set this to not loop. So we fixed that issue as well, and that's actually all we need to do to have a working spider monster. So I hope you found this video useful. If you have any further questions, then feel free to contact me in the support thread on the Unreal Engine forums. That's useful for more complex questions where I will often need to provide blueprint code and so on to explain stuff. For shorter questions, then you can go to the Dungeon Crawler Toolkit Discord, which is also linked in the description above, and you can just get in there to chat with me and with other developers using Dungeon Crawler Toolkit as well. We got a nice little community there, so please join us there and have fun creating dungeon crawler style games.